Here's how to solve 2D projectile motion problems in physics. So in this example, we have a ball being launched at an angle from the top of a building, and we're asked to figure out how far the ball lands from the base of the building. Now I know there are a lot of numbers in this problem, but here's a general strat to make it easy. Anytime you have an object moving in both the up-down and the left-right direction, the key is to write out the kinematics equations separately for each direction. Then you solve for the time t in one direction and plug in the same t into the other one. In this case, we're looking for the distance the ball travels in the x direction, which will be related to the time it takes for the ball to fall in the y direction from the top of the building to the ground. Now choosing which kinematics equation to solve with, we're going to use the second equation, because in this problem we're not given, nor are we asked to find, the final velocity. The next step is to write our kinematics equations out in each direction. Now when writing these out, you'll notice that there are two initial velocities, one for the x direction and one for the y direction. However, in this question, we are only given one value for the initial velocity, 20 meters per second. But this is a velocity that points in both the x and y direction. The trick here is to break up the initial velocity into separate x and y components by making a right triangle and using some trig functions. So here the initial velocity in the x direction is 20 cosine of 30 degrees, while the initial velocity in the y direction is 20 sine of 30 degrees. Next we plug in for the variables we know and see how to solve for the variable we don't know, which is the final x position. Starting in the x direction, we're going to call our initial position equal to 0 and plug in our value for the initial velocity. Looking at the acceleration in the x direction, this is going to be 0, because there are no forces acting on the ball in the x direction. And by F equals ma, if the net force is 0, so is the acceleration. Now looking in the y direction, we know our final y is when the ball hits the ground and is equal to 0, while the initial y is at the top of the building when y is equal to 40. Again, we plug in our initial velocity, but looking at the acceleration, we are now going to use negative 9.8 meters per second squared. This is because any object moving freely through the air is going to feel a downwards acceleration in the y direction due to gravity. After simplifying a little bit, we have two easier equations where we can solve for the final x once we have the time t. This is where we're going to use our y direction equation to solve for t, since the time when the ball hits the ground is the same time when it's at its maximum distance from the building, x final. Using the quadratic equation, this gets us two solutions, t equals negative 2 and t equals positive 4. In this case, we're going to pick the positive t value, since the negative t value doesn't make any sense, unless you have a time machine. The last step is to plug in t equals 4 to our x direction equation, which gives us a final distance of 69.3 meters. And there you have it. That's how to solve for 2D projectile motion problems in physics.